Hello, young math Padawans. It's Mrs. Angel with your quick lesson for today on how to find the area of a regular polygon. So before we get started, let's just review and recap what a regular polygon is. A regular polygon is a figure, a closed figure with any number of sides where all of the sides are congruent. In addition to that, all of the angles inside of the polygon are also congruent to each other. So our perfect example of a regular polygon would be an equilateral triangle. An equilateral triangle is a triangle where all three sides are congruent to each other and all three angles are also congruent to each other. Now, to find the area of a regular polygon, we do have a formula, but it involves some vocabulary that we haven't talked about yet. So we're going to grab these notes and get started with number one. So number one is an octagon. And the reason I know that is because it has 1, 2, 3, 4, 5, 6, 7, 8 sides. All of these sides are congruent to each other because this is a regular octagon, and all of the angles are also congruent to each other for that same reason. Now, to find the area, which is everything inside of this octagon, we need to first understand some vocabulary here. Let's start with the basics. This is called a side, which I think we already know that. In fact, we define an octagon as having 8 sides. So any one of those parts from one vertex to another we call a side, and we use the variable s to represent that. The point directly in the middle of the polygon is called the center. And it's very similar to the center of a circle. If I were to draw a circle around this polygon, the center of the circle is also the center of the polygon. Or when I start at the center and I go to any point on the circle, let's say I go from the center to this point here, that's called a radius of a circle. So when we have a polygon inside of a circle, it's called inscribed. So this is an octagon that is inscribed of a circle, which basically means each point on the octagon is also a point on the circle. So every single one of these points on the octagon, every single one of those vertices between each side is equidistant from the radius. So I could go in here and show there's a radius there, here's another radius here, another radius here, and so on and so forth around the entire octagon. So I can break up this octagon into a bunch of different triangles. How many triangles? 1, 2, 3, 4, 5, 6, 7, 8. So I've now created 8 congruent triangles because they all have the same side lengths. So now that we have a better understanding of this octagon, I'm going to actually get rid of the circle and just look at this one triangle that I've created. Now, to find the area of this whole octagon, I need to start by finding the area of this triangle. Because if I can find the area of one of those triangles, all I have to do is add it up 8 times, and that will give me the total area of the octagon. So what I like to do is I like to take out the triangle to take a look at it on the side. So let's say I take out the triangle just so that I can look at it outside of the octagon. So here is our triangle. And let's fill in what we know about this triangle. Well, we know that because this is the base of the triangle and it's the side length, that measure must be 9.9. So the base of this triangle is 9.9 units. We also know that the height of this triangle, not the radius, but the height of this triangle is 12 units. So what's the formula for area of a triangle? It's okay if you forgot, it's really common. The formula for area of a triangle is 1/2 times your base times your height. So how would we find the area of this triangle? We would do 1/2 times the base, 9.9, times the height, 12. Take all that information and pop it into a calculator, and you end up with 59.4. But here's the thing. That's not the area of the octagon. That's just the area of this one triangle. So how would we find the area of the octagon? Well, remember, because this is inscribed in a circle, each one of these triangles is congruent to the last one. So if each of these triangles is congruent to the other, that means they all have the same area. They all have an area of 59.4. Well, how many triangles are there? There are 8 triangles because this octagon has 8 sides. So to find the area of the octagon, we would just take the area of one of those triangles, 59.4, and multiply it by 8. Grab a calculator, and this total area is 475.2 units squared. So in an octagon, in any regular polygon, you only need to know 3 pieces of information. 1, you need to know the length of one of the sides. 2, you need to know the number of sides, which you can do just by counting. So 3, think about what we needed to find that area of the triangle. We needed the height of that triangle that was perpendicular to one of the sides or the base. However, we don't call this a height in a polygon. We call this an apothem, A. So let's derive our formula for area of this polygon. The area of this polygon is, first, the area of the triangle. So if you think about the formula for area of the triangle, it's 1/2 times base times height. But now let's fill in what it's actually called with this diagram, with this octagon. The base is one of the side lengths, S. And the height is called the apothem. That will give you the area of that one triangle. And then to find the total area, you just need to multiply it by the number of sides. In a textbook, you won't see it written like this. You will see it written as 1/2 apothem times the number of sides times the side, or 1/2 times apothem times perimeter, because perimeter is basically just the total number of triangles. But keep in mind, all you have to do is find the area of one of those triangles and then multiply it by the number of sides. So number 2 is an equilateral triangle, and I know this because it's a regular polygon. But we can't use our normal formula because we don't know what this entire height is of this triangle. Right now, we're only given the apothem. So we're going to use our formula, area equals 1/2 times, and then I think base times height, the side length times the apothem times the total number of triangles we're dealing with. Sometimes it helps to draw in that triangle. We're dealing with this triangle right here. If we can find the area of that triangle, then we can find the total area of the regular polygon. So let's identify our parts here. We have our apothem here is 4. That's the height of our triangle. Our side length here, or the base of our triangle, is 14. That's our side, 14. And the total number of sides in this polygon are 3. So if we know the apothem, we know the side length, and we know the number of sides, we just have to substitute that information into our formula. So area equals 1/2 times your base, which is your side length, 14, times your apothem, 4, times your number of sides, 3. Pop that thing into a calculator and you have your total area. The area of this polygon is 84 square units. So the side length of this polygon is 14, which means if I were to create my triangle by connecting the two radii, the base of this triangle is 14 units. The apothem is the perpendicular bisector, or the distance from the center to the side, and that has a length of 19.2. And this polygon has 1, 2, 3, 4, 5, 6, 7, 8, 9 sides, meaning it is a nonagon. So we start by finding the area of our triangle and multiply it by 9. So here we go. Area equals 1/2 times the base of our triangle, 14, times the height of our triangle, or the apothem, 19.2, times the number of sides, 9. Pop that thing into a calculator and you end up with 1,209.6 square units. I ended up with a side length of 17.3, an apothem of 5, and the number of sides, 3, which comes out to 129.75, but the directions did say to round to the nearest tenth, so that would be 129.8 square units. That's it for today's lesson. I will see you next time.